my last video on this topic, I attempted multiple experiments to see if it was possible to cause a bleaching effect by leaving various negatives in normal, non-rapid fixer for an exorbitant amount of time. This time, however, I'm bringing out the big guns. I ordered the most special boy, most highly concentrated rapid fixer you can possibly get. This pack of Kodak color negative fixer and Replenisher concentrate is enough to make 6.6 gallons of fixer solution. These bottles are 5 liters each and mix at a 1:4 ratio with water to make the working solution. That's 20% concentrate and 80% water to make that a little bit more clear. This is also the only type of fixer you can buy on its own that is not acidic and is specifically made for color film. In the last video, I pointed out how Kodak says in a footnote buried in a manual that the pH of the fixer should never fall below 5.5 because it will affect the dye stability of their color negative films. What does that mean in real life? Well, I don't know, and it seems like no one else has ever tested that to show the type of degradation that could happen when you fix your color film using an acidic fixer compared to a neutral one. But allegedly, your colors will get wonked up over time if you fix using an acidic fixer. And almost every fixer you can buy is going to be slightly acidic, with the exception of fixer that comes in kits for color film. And of course, there's also my fixer. This is the 25 liter version, which specifically lists the pH as 6.2 in the safety data sheet. There's also a less concentrated version of this same stuff, which costs a little less and only makes 10 liters, but the pH says it's 7.5, probably due to the addition of some basic chemicals, which are absent from the list of ingredients for my 25 liter version. I was actually going to buy that less concentrated 10 liter version, but for whatever reason, the less concentrated one had a significantly higher price to ship to my location than the more concentrated one, so I figured I'd just spend the extra $12 and get the good stuff. Also, if you're looking around for this stuff, you might find this, which looks pretty similar, but is actually for black and white film, which means it's more acidic. Specifically, this has a pH of 5. The fixer I bought states that it contains 95 to 100% of a 60% solution of ammonium thiosulfate, which is commonly referred to as rapid fixer. The 10 liter version of this fixer contains 40 to 60% of the 60% ammonium thiosulfate solution, so it's about half as concentrated as mine, and thus makes about half as much working solution when mixed with water. Usually safety data sheets don't list percents like this as a percent of a percent solution, they just list the amount straight up. Like Ilford Rapid Fixer is listed as having 36 to 50% ammonium thiosulfate, so that would be pretty similar concentration to the one I have, and it's also mixed at the same ratio as the stuff that I have. But the Ilford Rapid Fixer is acidic since it's intended for black and white film, and there's a bunch of other preservatives and stuff in it too. The ammonium thiosulfate on its own, before it's absorbed other stuff from the process of fixing film, is pretty safe to handle. It does have a slight sulfury smell, kind of like fireworks if you get it on your skin, but otherwise just take basic precautions. You don't have to worry about fixer until it's been saturated with silver. Then it becomes kind of an issue to dispose of because then it will kill the bacteria in the drains and it will corrode stuff. But fresh ammonium thiosulfate fixer is totally safe. In fact, it's also used as a fertilizer in the exact same concentrations as photography fixer, but farmers call it ATS fertilizer. And they pay, $300 per ton? That's 180 gallons of fixer concentrate. That would make about 900 gallons of working fixer solution, which is pretty close to this much, just to put that in perspective. So, if you live out in cornland, maybe ask your local farmer if he'll hook you up, cause us film photographers are pressed into paying exorbitant prices for common chemicals. Anyway, now that my ranting and explanation as to what I'm using is over, now I can finally move on to my experiments. I will be using the exact same negatives that I used in my previous video. Well, except the glider one. I had 2 single frames in my archive sheet and I pulled out the wrong one thinking it was the test subject. I mean, they both have gliders in it, come on, give me a break. But that means this negative has not felt the wrath of 52 hours of excess fixing from the previous video. So technically, it's fresh. I still don't know exactly what film stock this is, but in the comments of the last video, someone pointed out that yeah, it's definitely motion picture film because the sprocket holes, which is something I totally forgot about. And that also means that back in the 70s, people were doing the exact same thing we do with motion picture film in cameras today. Kodak Alaris hates this one weird trick to get the best film for less money. As for the other test subjects, my black and white negative is Arista EDU 100, which is just Fomapan 100. I also have Ektar 100 and Cinestel 800T, which I'll refer to as Vision 3 because that's what it actually is. For my first experiment, I decided to go with just the black and white negative. That way, if the test just like completely erased the negative, it would only be this one shot, which I have a backup of anyway. And there was a good possibility of that happening, because for this first test, I didn't dilute the fixer at all. That's right, I'm fixing in the raw concentrate. I specifically poured 200 milliliters so I could later mix this in with 800 milliliters of water to get 1 liter of working solution. But right now, I'm just fixing in this concentrate. So I gave my negative a good rinse to soften the emulsion and clean off any dust or debris, and I put it in the concentrate for 10 minutes. As you can see, this concentrate is very viscous and dense. The film really wants to float to the top, but I eventually got it kind of balanced so it was fully submerged. And throughout all of these tests, unless otherwise noted, there was no significant agitation, and everything was kept at room temperature. So after the 10 minutes were up, I rinsed it off, hung it to dry just like in my last video, then I scanned the negative. And when compared to the scan I did right before performing the experiment, it's slightly brighter. I did a 31 by 31 average point sample in a low density area of the negative. And for this test, I got a value of 120 versus the 118 of the initial scan. So yeah, the film faded by 2 grayscale values. Wow. Well, I guess that kind of ends the video. Who's gonna fix in the concentrate for 10 minutes? But of course, I still had to test the color negatives. So I went and took all my negatives, including the black and white one, and placed them into the concentrate, this time for 30 minutes to really see if something significant happens. Now, during this test, I wanted to just check to make sure that this fixer was actually capable of fixing film, you know, just to be safe. Maybe it's like defective or something. So I got a little bit of undeveloped film and put a drop of fixer on it, and I waited and waited some more, and it didn't really look like anything was happening. I rinsed it off, and as you can kind of see, it sort of fixed the film, but only in like certain places. It was kind of grainy looking. Weird. I thought maybe my little drop I put on the film was like not enough or something, so I washed it off, then I dipped the film in the concentrate again, and immediately it was fixed. Oh my god. Did you see that? Instantaneous. I guess they call it rapid fixer for a reason. Okay, you see the emulsion? I'm just gonna dip it in here. Bloop. And it's gone.
It didn't do that though when it wasn't wet.
So basically, what this means is that you actually need the film to be wet in order for the reaction to occur. But why is that the case? I tried to figure this out, and it could be a number of things. The fixer concentrate might just be so viscous that it can't penetrate the dry emulsion at all. Wetting the film might allow the thick fixer to pass into the emulsion and actually remove the silver halides. It could also be caused by some kind of mass transfer limit, and when water is added, it dilutes the fixer itself in that area, thus allowing it to fix. Or maybe it has something to do with hydrodynamic boundary layer theory, blah blah blah. Anyway, the point is, fixing dry film in the concentrate doesn't seem to work quickly or even at all. And funnily enough, for the test that I was running, I actually forgot to wet the film first. I put all the negatives in dry. When you drop your tweezers in the fixer, so you have to use other tweezers to get your tweezers out because you don't want your fingies to stinkies. So after the 30 minutes were up and the negatives had a chance to dry, since I do wash them after to get the fixer off, you can see from the results that, yeah, basically nothing happened at all. The black and white negatives are almost visually identical. The histogram doesn't really move at all when comparing this test and the previous, and my point sample shows no change at all. It's still a value of 120, same as the last test. Between the previous test and the untested negative, you can clearly see the entire histogram moves over a tiny bit, but this didn't happen with the 30-minute dry test. And these results are almost identical across all of the other test subjects. The Vision 3 had some physical warping, but the histogram didn't move at all. The glider negative did slightly change overall, but also some damage to the emulsion was induced. These white dots were probably caused by mishandling, and over the course of these next tests, you'll see them grow larger. And also, for whatever reason, this sticky stuff that was on the negative got thicker for some reason. The Ektar results are the exact same as the Vision 3, including the warping. No apparent change occurred, and the histogram didn't move at all. For each color experiment, I also measured a 31 by 31 average at 2 sample points, one on the film base and one on the image itself. The film base for the Ektar negative increased by 1 red value. The other sample point, which is this nice smooth wall area, increased by 1 red and blue value. For Vision 3, the film base somehow got more dense in this test by 1 blue value. But these single value changes could just be sampling variance error, or maybe there was more dust in that specific location for that specific scan. Or maybe not. I also sampled this area of bricks and got 1 value increase in the red channel and 1 for the blue channel. When the RGB values increase, that means the film is fading since more light is getting through. Finally, the glider, the film base sample, and this guy's whitish helmet. It's white in the inversion, not the negative, obviously, but both those areas increased by just 1 red value. So from these results, I think it's safe to say that dry film placed in the most concentrated ammonium thiosulfate you can get doesn't actually do anything to the negatives. For the next test, I made sure to thoroughly wet each negative to make sure the emulsion was saturated with water. Then I placed all of the negatives in the concentrate again for another 30 minutes. Surely this one will cause a change, right? But the results of this test were more of the same, with the most significant changes happening to the black and white film. This time it increased by a whopping 2 grayscale values, and you can clearly see the histogram has shifted to the right. The color film is a little more interesting. The Vision 3 seems to have de-warped itself, but no apparent change in color occurred. The histogram appears identical. For the film base, the RGB values all decreased by 1, which means it's now darker, the opposite of what I expected to see. The brick area also decreased by 1 red value, so no fading at all occurred in this test. And again, there were nearly identical results from the Ektar 100, this time with no RGB value change at all in either of the sampled areas. The glider showed the most amount of change. First off, you can see the damaged areas have become brighter, but also that sticky goo stuff almost completely washed off the film when I did my post-experiment rinse. The negative is visually brighter overall, the base increased by 1 red, green, and blue value, but the helmet changed significantly. 4 red values, 1 green, and 1 blue. This is similar to the results of the last video where I noticed that the red channel is always the most affected. However, these results still show no real significant change and very little, if any, amount of so-called bleaching. So I thought, maybe the concentrate really just can't work this way. Maybe it does need to be mixed into a working fixer solution. So I took my 200 milliliters of concentrate and I mixed it with 800 milliliters of distilled water. This gives me 1 liter of working fixer solution, and I had to mix this using one of those like 3-bottle goofy Professor Layton-esque puzzle type situations where I didn't have a container that could hold all the liquid at once. Well, at first.
Look at that. That's crazy.
This is the fun part where I get to have open bottles everywhere. And I'm basically just going to do this a bunch until I feel like they're evenly mixed. See, if I had a 1 liter jug or bottle, this wouldn't be such a weird situation. Don't know why I didn't do this earlier. This seems like the smart thing to do. So now with my working, thoroughly mixed fixer solution, I again ran the same test, wetting all the negatives and leaving them in the fixer solution for another 30 minutes. And the results of this test are even stranger. The black and white negative didn't change at all, whatsoever. Same values, same histogram. The Vision 3 did change a tiny bit. The overall image does appear slightly brighter, and the sample values did move significantly more than before. The film base went up 2 red and green values, and only 1 blue value, but the brick sample area actually decreased by 1 red, with green and blue remaining identical to the previous test. Once again, the same results with the Ektar. Gee, who would have guessed modern Kodak films react in a similar way? The film base increased by 1 red, green, and blue value, with the other sample area only increasing by 1 green value. Unlike previous tests, the glider did not show a significant difference. The base increased by 1 green and blue value, the helmet increased by 1 red and blue value, but looking at the histogram, this time it appears like the red channel didn't move at all, but the rest of the image slightly did. So it does seem like water might play into this somewhat, but diluting your rapid fixer to the working solution concentration does not seem to allow the fixer to fade the negatives more effectively, though I'm sure it certainly does allow it to actually fix film when you use it as intended. The thing is, I think the fading we see in these experiments and in the previous video are a result of a secondary reaction. I don't actually think there's a fixing reaction going on, at least not in the color film, because there should be no silver at all in the color film. The black and white, maybe. Maybe the fixer is somehow able to slowly dissolve the metallic silver into ionic silver, but I really have my doubts. So I decided to run another test. This time, a big one, 12.5 hours overnight in the fixer solution. If this doesn't show a result, I don't know what will. Thankfully, it did show a result, just like not really that much of one. The black and white negative clearly got brighter, this time by 5 grayscale values. The histogram is also noticeably shifted over. So yeah, I mean, this is the same exact thing we saw in the last video, a slight amount of fading if you push your fixing times to the extreme. The glider image also shows a noticeable difference. Again, the red channel is the most affected. The film base increased by 3 red, 2 green, and 1 blue value. The helmet changed much more, with the red channel increasing by 7 values, but the green and blue only by 1 value each. This time you can see even more white dots from negative damage. I guess I scratched this one, probably while trying to balance it in my beaker so it wasn't touching the other negatives.
I'm ruining it. Oh, I had it so perfect. I had everything perfect. Come on. You go over here. Okay.
As for the Vision 3 and the Ektar, there certainly is a change, but for over 12 hours, I was expecting a lot more. The film base for the Vision 3 increased by 5 red, 5 green, and 2 blue. The brick sample area increased by 2 red and green values, but only 1 blue value. For the Ektar, the film base increased by 2 red and green values, and the sample area only by 1 red value. I decided to do this next test on the black and white film only. This time I wanted to test my acid fade theory. First I poured out a tiny bit of my working fixer into the beaker, then I mixed in a bunch of sodium ascorbate. I thought surely this source of ascorbic acid would be acidic. Well, no. I tested the pH and nothing changed. Turns out sodium ascorbate is actually slightly basic.
pH strips. No one's saying it's more basic. Need a better acid, I think. I think I know what to use.
Okay, well, I do have something else that I know is acidic. The Baby Boomer lemon juice, filled with toxic preservatives not fit for human consumption, but great for bulk experimentation. I put in about as much lemon juice as I had fixer, followed by my black and white negative, and I let it sit in this concoction for 15 minutes. And it actually did make a slight difference. The sample point increased by 3 grayscale values, and the image is overall noticeably brighter. Okay, how about another test? So far for all of these, I've been doing basically no agitation. For the next test, I'll put the black and white negative in my beaker with a bunch of fresh fixer solution, and I did 5 minutes of continuous agitation. This time the change was far more noticeable than the lemon concoction. The sample point increased by another 3 values, however the histogram has shifted noticeably more, meaning the entire image got brighter. So agitation certainly plays in to the possibility of fading negatives with fixer. The next test is something someone in the comments of the last video suggested, and this time I decided to include the color negatives as well, in this punishing, extremely harsh 24-hour test of water. Yeah, 24 hours in water from my sink. I also put it by my window so the sun was shining on it, but after 24 hours in that water, the results were very surprising. The black and white film barely changed at all, though my sample point actually dropped by 2 RGB values. Huh? So the water made it denser? It reverted? The fading? What? Surely this must be a measuring mistake, right? But if you look at the glider negative, the same thing happened. The film base dropped by 6 red values and increased by 1 green. In fact, the red value is now lower than it was before I ran any tests on this negative. The helmet sample point shows the same results, a 5 value red drop and a 1 value blue increase. However, the other color films gave the complete opposite results. The Vision 3's film base gained 1 red and blue value, but 4 green. On the bricks, 1 red and 3 green, but no change to the blue. The Ektar negative was even more affected by the water. The base gained 1 red, 3 green, and 3 blue values, and the test point 1 red, 3 green, and 2 blue values. So clearly, the different kinds of film are reacting differently. Black and white was the least affected by water. The vintage 1970s mystery cinema film was restored using water, and the modern Kodak films were faded even more with the water. Very strange, and I don't know what to think of this except that color timing guys in Hollywood probably had a very short life expectancy considering how easy it is to manipulate the color of the developed negative unintentionally. For a final test, I decided I would do something a little extreme. All of the negatives in a beaker of pure lemon juice for 25 minutes. The most interesting thing about this test was I could physically feel a difference in the emulsion before and after the test. Before this test, while wetting the negatives, they feel sort of smooth on the emulsion side, almost slippery, kind of like soap. I could feel this on the vintage film the most throughout all of the tests so far, but one thing I did notice is that all of the color negatives became softer feeling as I performed more and more of these tests. But after I took the negatives out of the lemon juice to rinse them off, they felt completely different. No longer did the emulsion have a slippery, smooth texture. It now felt more plasticky and hard, which makes a lot of sense. You've probably heard about hardening and non-hardening fixer. Well, guess what is used for the hardening agent in fixer? Citric acid, which is lemon juice. And this makes even more sense because apparently hardening fixers were more important back in the day, but now modern film doesn't need it, at least as long as you don't perform multi-day tests on them which remove whatever baked-in hardening agent they have. The vintage film felt soft the entire time because it doesn't have this built-in hardening of modern film emulsions. And all hardening does is strengthen the emulsion while it's wet. Once it's dry, hardening apparently doesn't make a difference. The damage on the glider negative is certainly because the emulsion is a lot weaker with this vintage film. Throughout my tests, you could actually see a piece of the emulsion slowly tear off and eventually forming a hole. As for the actual results of the 25-minute lemon juice test, the black and white film increased by only 1 value at my sample point, but you can see the histogram has noticeably shifted. And the color film, not much changed. The Vision 3 film base increased by 1 red and blue value. The brick area went up by 1 value for all 3. And you can visually see a slight difference. Ektar's base went up by 2 red, 1 green, and 1 blue. The test area went up by 1 red, but down by 1 blue. The glider did show a slight visual change. The film base increased by 2 red and 1 blue values, and the helmet increased by 2 red and 1 green. So maybe acid degradation might have something to do with the film fading, but I'm still not sure about that. Actually, I did this final acid test as part of a longer term experiment. I figure maybe in a year or so, if someone reminds me, I'll pull these acid treated negatives out and rescan them again to see if the colors have shifted at all. Since these negatives were exposed to a very acidic environment, they should show dye stability problems. Maybe? Actually, this got me thinking, and I wonder if my negatives have degraded at all from the previous video till now. So I loaded the scans from the last video and compared them to the initial untested scans from this video, and the results are really strange. The final scans in the last video were almost all brighter, as in more faded, than they were on the initial untested scans for this video. So that means while in storage, the negatives sort of self-healed and became more dense, the black and white negative had the least change, going from 119 in the final test of the last video to 118 before performing any experiments in this one. Vision 3's base went down by 1 red value, but actually increased by 3 blue values, meaning the blue of the film base faded more over time, while in my archive sheets inside of a box somehow. The same is not true for the actual image, where the brick sample point went down by 2 red, 1 green, and there was no change to the blue values. Ektar is similar. The film base went down by 4 red, 1 green, and no blue, while the sample area went down by 8 red, 4 green, and 2 blue. So a significant improvement in density occurred. I can't use the glider image I used throughout this video, but I did pull out the correct one from the previous video just to make a new scan to see if anything changed while in storage. The film base decreased by 1 red value, and the sample point on the glider's wing decreased by 3 red and 1 green. So there was a change in storage across all of the negatives, even slightly. And these changes mostly made the image darker, effectively reversing the abuse these negatives received from the previous video. But we still don't know why it even fades at all. Chemically, there should be no reaction. Maybe someone that uses water with chemicals that react to the film differently causes bleaching. Maybe heat and agitation will fade the film quicker. And maybe, this one I can't exactly test, but maybe bleaching only can happen during the initial fix when the photos are developed, and afterwards the image is locked in, though that doesn't really make sense either and shouldn't matter, but who knows? Maybe there's a chemical added to other brands of fixer which causes bleaching. Maybe fixer that is nearly exhausted and filled with all the other byproducts of fixing is capable of fading film more than fresh fixer. You would think with something as simple as fixing film, there wouldn't be this many possibilities and variables, but there are, and there's just too many things we don't know. I still think, as I said in the previous video, that overfixing might cause deposits on the film, but in this video you can see most of those deposits I pointed out in the previous video just vanished after a few tests, or were water spots, not actual particulate on the film. In the last video I mentioned slight detail loss, but really it's the ever so slightest amount of shadow detail loss. Something that you have to like super pixel peep to see. And you're probably going to clip those areas anyway when you boost the contrast, so you're not missing anything. And besides that, I saw no discernible loss of any detail in any of the images. So I'd say 99% of people can stop worrying about overfixing no matter what you're doing. Unless you're fixing in a constantly agitating, super hot environment for a really long time, then maybe they'll fade a little bit. Actually, the one thing to really keep in mind is fixing vintage negatives with modern chemicals, because the emulsion is a lot more fragile. But still, it's probably fine. Like, let's be real, I kind of abused these negatives. I wasn't exactly babying them.
For this test, I'm going to drop my negative on the floor.
But that's it for this video. I'm gonna try to make some more casual photography related stuff in the future, since these experimentation videos take quite a long time to make. Anyway, make sure you get subscribed, make sure you like and share the video, join channel members or donate so I can keep making videos like this, and I'll be back next week with a brand new video.